All right, everyone. Hello and welcome to the fourth screencast for Chapter 8. This screencast tends to be, this material anyways, tends to be one of the more complicated things that we do during the semester. If you thought the last few were complicated, we're going to add a whole nother layer of complication here. But basically all we're doing is we're taking that big chart that we had there at the end of screencast 3 where we had, what did we have? We had fixed costs, variable cost, total cost, average variable cost, average fixed cost, average total cost, and marginal cost. We're going to put those on a graph, basically. And we're going to get these things that we call cost curves. And we're going to use these cost curves to talk about the ways that firms make different decisions, all right? Okay, so the first one we're going to look at here is total cost, all right? So this is what total cost looks like. At the beginning, you have this, it's increasing as we produce more Big Macs, right? Maybe I should point at it with this. There we go. So as we get more Big Macs, the total cost increases, all right? But remember, we can break down the total cost into two different components. The total variable cost, which is as we produce more Big Macs, we use more and more of those variable inputs, right? Like labor or the cost of ingredients, the cost of beef, the cost of the bun, that sort of stuff. So total variable cost tends to go up like this. And again, they have the same shape. At the beginning, the cost goes up, but it goes up at a decreasing rate. And then we hit a certain point at which the cost is still going up as we produce more and more, but the cost goes up at an increasing rate. And we're going to see why as we kind of break this total cost into the two components. So there's total variable cost, and then this is total fixed cost. And now you can see that total cost is just the sum of these two curves. It's the sum of total variable cost and total fixed cost. So here at 1 unit, right, the total fixed cost is here. The total variable cost is, or here at 0, I should say, there's none. So I add 0 plus 100 and I'm at 100. Now as I move up to maybe, let's see, looks like 25. So at about 25, right, this is the total variable cost. This is the total fixed cost. And when I add those two up, right, I add this to this, right? So I'm adding this distance plus this distance, right, that amount, right? So 100 plus what looks to be like 75. I add those up and I end up here at, say, 175, all right? So we're summing the height of the total variable cost and the height of the total fixed cost. But the total fixed cost is always 100, right? Notice when we get to this point where total variable cost equals total fixed cost, all right, then that is the point at which the total cost curve now starts increasing at an increasing rate, right? As the total variable cost keeps increasing, then now we get this slope. So on this part, we were basically we had the total fixed cost that was flat, and as long as variable cost was below it, then our total cost only grew at a decreasing rate. But once we pass this point where total variable cost is more than total fixed cost, the total variable cost increases overwhelm that flat effect there, and we get increasing total cost on that part of the curve. All right, so let's look at these cost curves. The cost curves we're going to use a good bit in this class, and what I'm going to show you here is going to be the typical cost curves. We're going to look at other versions of it, but this one will get us started. So here our cost is on the vertical axis, and the quantity of Big Macs produced is on the horizontal axis, and this is the what the marginal cost curve typically looks like. All right, so as we produce more and more Big Macs, the marginal cost of each additional Big Mac, it falls at first, right? Because as we're producing more, right, we have that increasing marginal product, if you remember from a couple screencasts ago. And so that means that as our costs are increasing more slowly than the quantity, right? And so if the denominator gets bigger than the numerator, then the number gets smaller, right? So you go to a half, a fourth, eighth, the number gets smaller. But eventually that increasing marginal product turns into a decreasing marginal product. And because of that, the marginal cost then begins to increase, and it increases quickly, and it does so without ever going back up, changing the direction. It just keeps going up, up, and up. All right. So now the next one I want to bring in is the average variable cost. So average variable cost is the, remember, it's the variable cost at that level of production divided by the quantity. And so at first you kind of get some returns to specialization as you add, as you produce more and more stuff, but eventually as you're producing more and more, there are those congestion problems that we talked about with marginal product. And so it starts to go back up. All right. The next one I want to bring in is average fixed cost. And we don't always put this one in the cost curve graph, but for the first time we did it, I wanted to go ahead and put it in here. And then the last one is the average total cost. And this one's going to be kind of key for us. What we're going to say is that firms produce, the efficient point for firms to produce is the quantity where average total cost equals marginal cost. All right. Marginal cost always crosses average total cost at its minimum point. So that's what we're trying to find. We're trying to find where is average total cost minimized. All right. So let's look at a couple of cases. At 50 here, notice that the marginal cost is way below the average total cost. All right. You can still produce stuff and your cost is not increasing. Your total cost is not increasing. So let's move up to say 60. Again, still, even though average variable cost is going to start going up, average total cost is still falling. Well, why is that? Right? If average variable cost is going up, why is average total cost still falling? Well, it's because, notice the average fixed cost is still falling through this. All right? And it's only after the point where average variable cost starts going back up, you still get a few more units where fixed cost falling overpowers the average variable cost. But eventually, that rising average variable cost overtakes the effect of the falling average fixed cost, and the total cost, which is the sum of the two, right? You can sum this height and this height to get the average total cost. The sum of those two overtakes it and it starts to go up. And that happens at the exact point where the marginal cost curve crosses the average total cost curve, all right? So that's this point here at 70. This, again, is the efficient point for firms to produce, where average total cost is minimized. Now, if they keep producing, if they produce more and more, that marginal cost increasing so quickly is it's not going to be worth it. The cost, their average total costs are going to start increasing, and so they're not going to be doing as best as they can. All right. So what is the relationship between marginal and average? All right. What is that margin and average relationship? How do we know if the average cost will increase or decrease when we produce more? So we compare the current average cost to the marginal cost of producing. All right. So a key phrase to remember is that the average is always chasing the marginal. All right. So, or average follows the margin. So notice when we start out here with a few Big Macs, right? The marginal cost is falling and it's pulling average total cost down. All right. Then we get where marginal cost starts to go up. But notice it's still below average total cost, right? So the average total cost is still being pulled down by the marginal cost curve. But then once marginal cost is above average total cost, right, then that's going to raise average total cost as we keep producing more and more Big Macs. So if the margin is above the average increases. If the margin is below the average decreases. It's just kind of a way to remember what the shape of these things look like. So a way to think about this, I think that's a little more concrete, is to think about two examples. So think about the class GPA or think about sports statistics. The first, suppose the class average on our econ exam is 85%. We don't do percentages in here, but just for this example, suppose the class average is 85%. And then Smarty McGenius here joins the class, and he gets 100%. So again, I added one more at the margin, and his marginal value was above the class's average value, right? So adding that one more, his marginal score was above the class average score. So what do you think that'll do to the class average? It'll increase it. So if the value of the marginal thing you add when we're increasing Big Macs, or when I add this guy to the class, is above the average for the class, then it pulls it up. So the average is always chasing the margin, right? Conversely, if I go back to that 85% class average, and I add lazy no studyson, and he joins the class, or she joins the class, like the case is in this picture, and she gets a 34 on the exam. Well, what does that do to the class average? Her marginal addition to the class is 34%, but what would that do when we add her in and take the average for the class? Well, it pulls it down, right? So the marginal always, if the marginal is above the average, it pulls it up. If the marginal is below the average, it pulls it down, all right? The class average falls there. So suppose LeBron James has a scoring average of 30 points per game, all right? If he has a game in which he scores 45 points, right? So his margin for that game is 45 points. What does that do to his average points per game? Well, it increases it. The average always chases the marginal addition of that next unit. So he plays one more game. His marginal points for that game are 45. So that's going to bring his average, his long run average of points up, right? If he has a game in which he scores 12 points, the marginal points is 12. That's going to bring his average down, right? It decreases his average. So the average is always following the margin in these graphs, right? I think both these examples are good ways to remember it for the cost curve graphs.